In the previous video of some analytical techniques, we studied about purification of solids and crystallization process. In this video, we will be studying about distillation process and solvent extraction. Distillation is a method which is used to separate volatile liquid from non-volatile impurities and liquids having differences in their boiling points. Volatile liquid is a liquid which catches fire easily and also evaporates. We are going to study three types of distillation processes. First is simple distillation, fractional distillation, and distillation under reduced pressure. Let us now start with simple distillation. How would you define simple distillation? Liquids which boil without decomposition at atmospheric pressure are purified using a process called as simple distillation. In this process, the liquid is first converted into its vapors by boiling, and these vapors are again condensed by cooling, which means the gas has now converted into liquid, and then this pure liquid trickles down in the receiver. Here is a diagram which represents the apparatus that is used to carry out the process of simple distillation. It consists of a round bottom flask which is fitted with a cork, and it has a thermometer that is inserted in the round bottom flask through the hole in the rubber cork. The round bottom flask has a side arm through which the condenser is connected. If you observe the condenser carefully, you will see that it is made up of a jacket and has two outlets. So the water will be continuously flowing inside the condenser. Through one opening, the water is going to enter into the condenser, and from the other opening, the water is going to go to the sink. The liquid which we want to distill is taken in the round bottom flask. This round bottom flask is then clamped to a stand. Depending upon the type of liquid, that is, whether it is volatile or non-volatile, the round bottom flask is placed in water bath, even on wire gauze or oil bath. The condenser is further connected to a receiver where the pure liquid is to be collected. When carrying out the process of distillation, care should be taken that the bulb of the thermometer should be just below the sidearm of the round bottom flask. So how does the process of distillation actually works? The round bottom flask is first heated. As the liquid reaches its boiling point, it starts boiling, and this is the time when the vapor rises up in the round bottom flask and enter into the condenser. Here there is water that is continuously circulating in the jacket of the condenser, which brings about the condensation of the vapors. That means because it is cold in there, it converts the vapors back into liquid, and the liquid which gets collected in the receiver is in the pure form. So this is how the distillation process works. There is one activity which is mentioned in your textbook. Let us now study that. The aim of the experiment is to separate the components of a liquid mixture containing acetone, which has a boiling point of 56 degrees Celsius, and water, which is having a boiling point of 100 degrees Celsius. So basically we are taking a mixture which is a combination of acetone and water. It is very much evident that acetone, which is having a lesser boiling point, that is 56 degrees Celsius, when compared with water, it shows that it is the one which is going to distill out first. The apparatus required to carry out this experiment are distillation flask with a condenser, two receivers, thermometer, etc. What chemicals do we require? Mixture of acetone and water. Now we move on to the principle. Acetone and water are two miscible liquids having a wide difference in their boiling points. Miscible liquids means they can easily mix with each other and form a one-phase solution, which means that if you mix the two solutions, you cannot differentiate where is the acetone solution and where is water. Acetone boils at 56 degrees Celsius while boiling point of water is 100 degrees Celsius. When the mixture of acetone and water is heated and temperature of the mixture reaches 56 degrees Celsius, acetone would distill off. When all acetone distills out and when the temperature rises to 100 degrees Celsius, water would distill out. How do you carry out the experiment? So we take the mixture of water and acetone in the distillation flask, or it is also called as the round bottom flask, and we need to arrange the apparatus. Then we have to heat the flask, keeping the flask on a water bath carefully. We are placing the round bottom flask on water bath because we are using a volatile liquid, that is acetone. At 56 degrees Celsius, acetone will distill out and it will be collected in the receiver. After all the acetone gets distilled, we have to change the receiver. Discard a few ml of liquid, like if in case there is acetone still present, and as the temperature reaches to about 100 degrees Celsius, water will begin to distill. This we have to collect in the second receiver. So this is how the distillation process is carried out. Now we'll just observe a video to understand the same.
I need to remove this nail polish. Nail polish can be removed by acetone. Acetone can be obtained by simple distillation.
The process of heating a liquid mixture to form vapor and then cooling that vapor to get a liquid is called simple distillation. Distillation is used to purify a liquid by separating the components of a liquid mixture. Let us perform an activity to understand simple distillation. Take a mixture of acetone and water in a distillation flask. Put a thermometer in it. Connect the flask to a water condenser. The condenser has cold water running through its jacket to keep the temperature cool. Keep a beaker at the outlet of the condenser. Heat the mixture, keeping an eye on the thermometer. When the temperature hits 56 degrees Celsius, acetone starts to vaporize. These vapors condense in the water condenser. The condensed acetone gets collected in the beaker. When all the acetone vaporizes, water is left in the flask. Acetone is collected in the beaker. In this way, acetone and water get separated by simple distillation. Boiling point of water is 100 degrees Celsius. Boiling point of acetone is 56 degrees Celsius. As there is sufficient difference between their boiling points, these components can be separated by simple distillation. Simple distillation does not work properly when difference between two boiling points is less than 25 degrees Celsius. This is because the components do not get separated and purified completely. If we repeat this process multiple times, we will be able to separate these two components. However, as this is very time-consuming, a special type of distillation called fractional distillation is used.
I hope you enjoyed the video. It is taken from Smart Learning for All. Now, we move on to study fractional distillation. When you take a mixture of two liquids and when there is no appreciable difference in their boiling points, then we use the fractional distillation process. Here is the assembly which is used for fractional distillation process. We can see a fractionating column which is fitted into the round bottom flask. When you start heating the mixture of the two liquids, the vapors that come out have to pass through these fractionating columns. The liquid, which is volatile in nature, has a lower boiling point, and the vapor of this volatile liquid are going to rise up in the fractionating column when compared with the vapors of the other liquid with a higher boiling point. Let us watch a video on fractional distillation.
Let's take an example. Separation of acetone and benzene by fractional distillation. As the difference in boiling points of acetone, whose boiling point is 329 Kelvin, and benzene, whose boiling point is 353 Kelvin, is only 24 Kelvin. Their mixture can be separated by the process of fractional distillation, using fractionating column. Let's see how this can be done. The mixture is taken in the distillation flask. Fractionating column is inserted between distillation flask and Liebig water condenser. The flask is heated on water bath. At a steady temperature of 329 Kelvin, acetone distills out, and is collected as first fraction, in the receiver. The vapors of benzene are cooled in the column, and liquid benzene trickles down back into the flask. When acetone is distilled out completely, the temperature starts rising, and the receiver is changed. When the temperature becomes steady at 353 Kelvin, benzene distills out, and is collected as second fraction, in the receiver. Acetone and benzene can be further purified by redistillation.
In this video, the mixture prepared was a combination of acetone and benzene. Of course, acetone was more volatile since it had a lower boiling point when compared to that of benzene. When the round bottom flask was heated, the vapors of acetone would rise higher in the fractionating column when compared with that of the vapors of benzene, since acetone is more volatile and also it had a lower boiling point when compared to that of benzene. First, the acetone will distill out, and then the vapors of benzene which were present along with the acetone in the fractionating column would distill back into the distillation flask until and unless acetone was not distilled out completely. Once the acetone is distilled out completely, then the benzene will start to distill out. So this was all about fractional distillation. Now we move on to study distillation under reduced pressure. Liquids which have a very high boiling point, or those liquids which decompose on heating, are distilled out using distillation under reduced pressure. In this method, the liquid is made to boil at a temperature below its normal temperature, that is the normal boiling point. And this is done by reducing the pressure on the surface of the liquid. The pressure of the liquid is reduced by using a water pump or vacuum pump. In soap industries, glycerol is separated from soap using this technique. Let us now watch a video to get a concrete idea of this process.
Distillation under reduced pressure. This process is used if the liquid has a tendency to decompose near its boiling point. The main neck of the flask is fitted with long capillary tube and the side neck fitted with thermometer. The side tube is connected to a condenser which is connected to the receiver at the other end. The receiver is connected to a pump which reduces the pressure. Under reduced pressure, the liquid will boil at a low temperature and the temperature of decomposition will not be reached. For example, glycerol boils with decomposition at 563 Kelvin, but if the pressure is reduced to 12 millimeters, it boils at 453 Kelvin without decomposition.
Now we move on to the last topic of this chapter, that is solvent extraction. If an aqueous solution contains an organic substance, then it can be separated by mixing the aqueous solution with an organic solvent in which the organic substance is soluble. Let us watch a video to understand the process of solvent extraction. This is the apparatus set up for carrying out the solvent extraction. The funnel here is called as the separating funnel. Through the funnel, the aqueous solution is added into the separating funnel. Aqueous solution contains an organic substance. So now we need to separate the organic substance present in the aqueous solution. So we are adding an organic solvent. The funnel is removed from the separating funnel and the separating funnel is closed with the help of a stopper. Before shaking the aqueous solution along with the solvent, care should be taken that the knob of the separating funnel should be closed. After time intervals, the knob is opened to release the pressure, which is built inside the separating funnel. After shaking the solution inside the separating funnel vigorously, the separating funnel is kept on the stand in a stable manner so that the organic substance is extracted or separated from the aqueous solution. So here you can see the organic substance has been separated. Now we need to keep a beaker below the separating funnel to remove the layers carefully. The knob is opened and we are collecting the first layer. Some part of the first layer can be discarded. The organic substance is then collected in another beaker. If the solute is less soluble in the organic solvent which is used, then the same amount of organic solvent is used to carry out the extraction repeatedly, and this is called as continuous extraction. When you take the organic solvent, care should be taken that it should be immiscible with the aqueous solution. Immiscible means the two solutions should not mix, which means it is going to result in the formation of two separate layers. When vigorous mixing is done, the solute gets distributed between the two immiscible liquids. The organic substance is extracted or separated based on the difference in the solubilities. Let us now watch one more video on solvent extraction.
Welcome to the video on the extraction of iodine from an aqueous solution. Pure iodine is a purplish solid. Iodine is slightly soluble in water. When iodine is dissolved in water, it gives an orangish colored solution. The aqueous solution of iodine is poured into a separatory funnel. Paint thinner is a colorless liquid. It is a mixture of organic solvents. Iodine is more soluble in paint thinner than it is in water. Paint thinner is added to the separatory funnel. Paint thinner is immiscible with water, and since the density of paint thinner is less than water, the paint thinner forms a colorless second layer on top of the orangish aqueous layer. Since iodine is more soluble in paint thinner than water, when the contents of the separatory funnel are mixed, the iodine will move from the aqueous layer into the paint thinner layer. The aqueous layer went from orange to colorless. This shows that the iodine left the aqueous phase. The paint thinner layer went from colorless to dark purple. This shows that iodine went into the paint thinner layer.
In this video, iodine was extracted using thinner as a solvent. So this was all about solvent extraction. With this, we finish off with your third chapter, that is some analytical techniques.